Natural gas is classified as Group D. The inside of a natural gas generator is classified as a Class 1, Division 2, Group D location according to NFPA 70, the National Electrical Code. For a Class 1, Division 2 Group D location, the wiring methods in Table 501.4 B apply. The following methods are commonly used. Firstly, rigid conduit or RGC. Exit the slab and run to the generator panel. Secondly, intermediate metal conduit or IMC. Do the same as RGC. Thirdly, Sealtite. Exit the slab, run less than 18 inches to the generator panel and seal at the panel entrance. Fourthly, threaded metal tubing. Exit the slab and run to the generator panel. If the Sealtite run is more than 18 inches, you would need to install another seal at the generator panel entrance and nipple into the panel. There are additional wiring considerations. Firstly, use flexible conduit or fittings for the final connection between the raceway and the generator panel to prevent strain on the conduit. Secondly, all conduit connections must be made up tight. Thirdly, use explosion-proof or Division 2 rated fittings and devices within the generator enclosure. Fourthly, all wiring must be done according to the manufacturer's instructions and the applicable codes and standards. Now let's delve a little deeper into each of these points. When we talk about Class 1, Division 2, Group D locations, we are referring to areas where flammable gases or vapors may be present under abnormal conditions. This classification is crucial because it dictates the type of equipment and wiring methods that are safe to use in such environments. Failing to adhere to these guidelines can lead to explosions or fires. Therefore, it's imperative to understand the specific requirements outlined in the National Electrical Code, or NEC. Group D specifically refers to atmospheres containing, among other things, natural gas, propane, butane, gasoline, hexane, naphtha, benzene, alcohol, acetone, lacquer solvent vapors, and similar flammable liquids, gases, or vapors. This means that any electrical equipment installed in an area classified as Group D must be designed and tested to prevent ignition of these substances. The fact that the inside of a natural gas generator is classified as Class 1, Division 2, Group D highlights the potential hazard present due to the continuous presence of natural gas. Even with a weatherproof enclosure, there's a risk of gas leakage or accumulation, particularly during maintenance or malfunction. The NEC provides detailed guidelines on how to mitigate these risks through proper wiring and equipment selection. Table 501.4 P in the NEC is a key reference for wiring methods in Class 1, Division 2 locations. It specifies the types of wiring that are permitted, as well as any additional requirements. Let's examine each of the wiring methods mentioned. Firstly, rigid conduit, or RGC, is a heavy-walled, threaded conduit that provides excellent mechanical protection and a tight seal against the ingress of flammable substances. When using RGC, it's essential to ensure that all joints are properly threaded and tightened to maintain the integrity of the system. RGC is typically used for long runs and in areas where the wiring is exposed to physical damage. Secondly, intermediate metal conduit, or IMC, is similar to RGC but has a thinner wall. It offers a good balance between mechanical protection and cost. Like RGC, IMC must be properly threaded and tightened to ensure a tight seal. IMC is often used in applications where RGC is not required but still provides a higher level of protection than other wiring methods. Thirdly, Sealtite, which is a flexible metal conduit with a liquid-tight jacket, is often used for short runs and connections where flexibility is needed. However, in Class 1, Division 2 locations, there are strict limitations on its use. Specifically, if the Sealtite run is less than 18 inches, it can be used to connect the rigid conduit to the generator panel, provided that a seal is installed at the panel entrance. This seal prevents the migration of flammable gases or vapors from the generator enclosure into the conduit system. If the Sealtite run is more than 18 inches, an additional seal is required at the point where the conduit enters the generator panel. This is to further minimize the risk of gas migration. The seal must be installed as close as practicable to the enclosure, but in no case more than 18 inches away. Fourthly, threaded metal tubing, which is another option for wiring in Class 1, Division 2 locations. It is similar to RGC and INC but has a smaller diameter and thinner wall. Threaded metal tubing is typically used for shorter runs and in areas where space is limited. Like RGC and INC, it must be properly threaded and tightened to ensure a tight seal. Now let's discuss the additional wiring considerations that are crucial for ensuring safety and compliance in Class 1, Division 2 locations. Firstly, the use of flexible conduit or fittings for the final connection between the raceway and the generator panel is essential for preventing strain on the conduit. Generators vibrate during operation, and this vibration can be transmitted to the conduit system. If the conduit is rigidly connected to the generator panel, it can lead to stress and eventual failure of the connection. Flexible conduit or fittings allow for movement and absorb vibration, thereby protecting the conduit system. Secondly, it is critical to ensure that all conduit connections are made up tight. Loose connections can create gaps through which flammable gases or vapors can escape. This can lead to a hazardous condition and increase the risk of ignition. Therefore, it's essential to use the appropriate tools and techniques to tighten all connections properly. Thirdly, the use of explosion-proof or Division 2 rated fittings and devices within the generator enclosure is a must. Explosion-proof equipment is designed to contain an internal explosion without allowing it to propagate to the surrounding atmosphere. Division 2 rated equipment is designed to operate safely in environments where flammable gases or vapors may be present under abnormal conditions. The selection of the appropriate equipment depends on the specific requirements of the application and the recommendations of the manufacturer. Fourthly, all wiring must be done according to the manufacturer's instructions and the applicable codes and standards. The manufacturer's instructions provide detailed information on how to install and maintain the equipment safely. The NEC provides the overall guidelines for electrical installations in hazardous locations. It's essential to consult both the manufacturer's instructions and the NEC to ensure that the wiring is done correctly. Furthermore, it is important to consider the importance of proper grounding and bonding in Class 1, Division 2 locations. Grounding and bonding help to minimize the risk of electric shock and provide a path for fault current to flow back to the source. This is essential for the operation of overcurrent protection devices such as circuit breakers and fuses. Grounding and bonding should be done in accordance with the requirements of the NEC. In addition to the wiring methods and equipment, it's also important to consider the overall design of the electrical system. The system should be designed to minimize the risk of ignition and to provide for safe and reliable operation. This may involve the use of intrinsically safe circuits, which are designed to limit the amount of energy available to ignite a flammable atmosphere. It may also involve the use of explosion-proof enclosures, which are designed to contain an internal explosion. Regular inspections and maintenance are also essential for ensuring the continued safety of the electrical system. Inspections should be performed by qualified personnel who are familiar with the requirements of the NEC. Maintenance should be performed in accordance with the manufacturer's instructions and the applicable codes and standards. The specific requirements for wiring in Class 1, Division 2 locations can be complex and may vary depending on the specific application. Therefore, it's essential to consult with a qualified electrical engineer or contractor who has experience in this area. They can help you to select the appropriate wiring methods and equipment and ensure that the installation is done safely and in compliance with all applicable codes and standards. In summary, understanding the requirements for wiring in Class 1, Division 2, Group D locations is crucial for ensuring safety and preventing explosions or fires. The NEC provides detailed guidelines on how to mitigate these risks through proper wiring and equipment selection. It's essential to consult the NEC, the manufacturer's instructions, and a qualified electrical professional to ensure that the installation is done correctly. By following these guidelines, you can help to protect people and property from the hazards associated with flammable gases and vapors. In these hazardous environments, safety should be the highest priority. It is very crucial to maintain safe operations when dealing with this type of environment by following the National Electrical Code, manufacturer's guidelines, and consulting with qualified professionals so that electrical installations are executed precisely to help prevent hazardous scenarios from happening. A natural gas generator that is well wired is vital to securing the functionality and safety of operations in places where flammable gases pose a risk. It is essential to implement safety procedures and to adhere to electrical codes in order to lessen the possibility of explosions and electrical shock incidents. This may entail putting into effect intrinsically safe circuits, utilizing explosion-proof housing, and performing consistent maintenance routines. By doing this, you contribute to safeguarding lives, preserving properties, and cultivating a reliable and safe workplace. To re-emphasize, remember the vital function of grounding and bonding systems in mitigating electrical hazards in locations categorized as Class 1, Division 2. Appropriate grounding practices contribute significantly to reducing the possibility of electric shocks and aid in the efficient operation of overcurrent protection equipment. By offering a route for the fault current to return to its origin, the system guarantees the prompt triggering of circuit breakers and fuses in the event of a fault, hence averting more considerable risks. The National Electrical Code offers exhaustive guidelines regarding the execution of grounding and bonding procedures, underscoring the necessity for strict adherence to these standards to guarantee the safety and dependability of electrical installations in environments susceptible to risks. Furthermore, keep in mind the relevance of preventive measures and routine inspections for maintaining electrical systems' integrity in hazardous settings. It is advised to schedule frequent inspections performed by proficient personnel that possess a thorough comprehension of the National Electrical Code prerequisites. Furthermore, adhering to the manufacturer's suggested maintenance procedures and complying with the applicable codes and standards is vital for maintaining the continuous dependability and safety of the electrical system. By prioritizing these preventive tactics, stakeholders can proactively tackle potential hazards, minimize downtime, and cultivate a safe operating environment. In conclusion, implementing the electrical standards in Class 1, Division 2, Group D places is crucial for assuring safety and preventing explosions or fires. To mitigate these risks, it is essential to adhere to stringent rules for wiring and equipment selection outlined by the NEC. Consulting the NEC, the manufacturer's guidelines, and enlisting assistance from experienced electrical specialists are crucial for guaranteeing correct installation procedures. By sticking to these rules, people can proactively safeguard people and property from dangers linked to combustible gases and fumes, fostering a secure work setting for everybody involved. Through keeping informed, staying watchful, and working together, we can boost safety protocols and avert accidents in potentially dangerous work areas. Lastly, it is vital to remain informed about changes to codes and standards to ensure continuous conformity. Electrical codes and standards are regularly updated to reflect technological developments, new insights, and field experience. Remaining informed about these updates guarantees that electrical installations adhere to the newest safety criteria, thereby reducing risks and boosting the effectiveness of electrical systems in environments susceptible to dangers. By embracing a culture of continuous learning and proactively integrating the latest regulations, stakeholders can improve safety procedures and cultivate a safer working environment for all.